Welcome to the Huddle. First of all, thank you so much for coming. It's like Saturday, as you said, and hard to make it sometimes. People are coming from, I heard, like really far away, like 40 kilometers, like really. So first of all, thank you so much for coming. I'm Sangarshanan. I work at the data platform team at Blinkit, as you can see from my bright yellow jacket, represent. And today I'm going to be talking to you about the event collection framework here at Blinkit and how we kind of use Apache API, how it comes together, and also break down like a couple of use cases where we actually bring all of this together and how people comes here, right? So we're going to start by asking a couple of questions. The first question here is why, right? So why do we need an event collection framework here at Blinkit? The answer is actually very simple. Some of you might have seen it because I didn't click well. We are basically an event-driven company. All of our services communicate through events, and basically events run everything here, right? So that's why we kind of need a way to collect these events, have insights, and not just information, right? And that brings us to the next question. How do we do that? Because events by itself are nothing but information, right? They tell you like how, with respect to time, how things are moving and how things are happening. But you want to convert them into insights, based on which you can actually say something and power a lot of use cases, right? So how do we do that? We do that by just aggregating our events, right? That brings us to the last question, which is what do we do? Now we have events, now we have those events aggregated, and we have insights. And what do we do with these insights is that we power a lot of observability use cases here at Blinkit. And by observability, I'm also making it like an umbrella term because it covers monitoring, it covers anomaly detection, us being proactive about the things that are happening on the ground so that we don't react, but we are proactive. We know things are going wrong even before they are escalated. And as you all might know, we are in the business of quick commerce. And the word quick is really important here. And our services and latency, SLAs need to be as fast as they can so that things don't get messed up on the ground and there are people depending. Cool. Now now that we answered the first three questions, this is a very short answer, right? So now I'm going to break those questions down. So the first question was events, right? We are event driven. And by that, I mean, we have events coming from various different places in the org. But just forgetting all of that, it's basically just front end and back end, right? Everything just can be put under these two umbrella terms. Coming to front-end events. Front-end events, by front-end events, I mean the events that are collected when you use the Blinkit app. And I hope you all have used the app. In the app, we collect events that are clicks and impressions. So you all might know about it, but basically clicks are what happen when you kind of click on something in the app, right? You click on a product, you click on a search bar, you click on anything, we have an event coming. And then impression is what you exactly see, right? You are on the home page right now, or you may be in the checkout page. So all these constitute an impression. And we have an event gateway that kind of pulls all these events that are emitted from our Android app, our iOS app, our web applications, and it's kind of pushed to Kafka, which is our messaging bus. So we have all of our front-end events that are coming to Kafka, right? And now going to a little bit more complex and personally the fun one, which is the backend events. Backend events are a little bit more complex because backend is more event-driven than the front-end, right? And basically all of our backend is made up of different teams and different microservices that communicate with each other through these events. So the first kind of events are the events that are pushed by services to talk to other services, right? So basic publish, subscribe model that we use. So for example, we have our order system that pushes an event saying that, you know what, I just got an order, right? And then this event must be listened by, let's say, our logistics team, which helps deliver those orders, right? Because they don't really know when an order came in. They only care about delivering it. right? So this event lets them know that, you know what, this is the order information, and, you know, make sure it gets delivered. And there are also several other teams that listen to these events. And we are also one of those teams, the data platform. We listen to these events directly through our messaging bus, which is again Kafka. And there are also some events that we need to push from these backend services that actually other services don't need to know about, right? Like, it's not always inter-service communication. We also have events that don't need to be communicated to other services, right? So there is no need for us to push them to Kafka, and the packet teams really don't do it. So what we have done here is we have come up with like a very basic mechanism where the backend teams, rather than pushing to Kafka, they just write to a log file, and we have a log aggregator that collects those logs as events. So we treat these as special logs, and these are actually events, right? So now, how have we built that?
One question is, it might be a very naive question. The first one which you said, when two applications are talking to each other, they are communicating through Kafka. You are also sniffing that packet. So somehow you are putting some sort of a load on the Kafka cluster, right? Because you are a consumer. So is that the right thing to do? Because those are transaction system and you are analytical.
So it's not exactly transactional, because we are. Those systems
are transactional.
Yeah. So
their communication is much more important than the analytics.
Yeah. So there are two types of things that happen here. One is what you said, right? Transactional things that happen in the backend database. We don't really touch those. Those are something that just run by the backend team, and we don't have any control, or we don't tail them much. We tail only those events that are pushed to Kafka. So those are not exactly transactional, but those are time-based. Right, so we push different events, and they just come in as logs. Right, events get pushed across time. They're not exactly kind of transactional, and that's why we use Kafka, because Kafka kind of helps us scale. We can have multiple producers and multiple consumers that kind of push to a single messaging bus, and we can scale by just increasing the partitions and stuff. So if, for example, we have like a core topic, right, which is, let's say, order events, right, where we push every order status. So those topics have very high partition, and they can scale really well. But there can be some events that people actually don't really listen much to. They have low partitions, and that's why we use Kafka, because it helps us scale in that way, so that the other services listening that are not affected by the throughput. Cool. So coming to the other events which are getting pushed locally by the services, we have a log aggregator, right, where we have a simple logging client. Let's call it Blinkit logger, where we just do Blinkit logger .emit and push a dictionary in Python, a hash map, depending on whichever programming language you use. No judgments. And what we do is, once the logs are pushed, it just gets written to a rotating file handler, and kind of every programming language has a native logger, right? So we have kind of a standardized logger that's kind of being used across services, and it supports a rotating file handler, right? So we write into that file, and there is a sidecar container that runs so that the main service is not affected, and the sidecar has only one job. It just reads the file and outputs the results, right? And then we tail the sidecar. We don't actually tail the backend services, so that the logs are not polluting things there, and only the sidecar has those events, right? And now that we have a sidecar and we have events, i.e. logs that are coming through, we listen to those logs using an really amazing open source project called Vector. Vector is by Datadog. And this is a really cool log aggregator where we just have like a YAML, of course, where we mention our source, which is our logs, and we mention a sink, right, which is going to be Kafka. And we can also have things like transformations that are happening in Vector. You know, we want to reformat, rename, filter events, right? We don't care about all events. We only care about events coming from the sidecar. So all those filters kind of happen inside Vector, and we get those events in the end to Kafka. So this is where our aggregation layer comes in, right? Now we have all our events, front end, back end, services communicating across, and services that don't need to communicate. All those events are now coming to Kafka with the platform that we have built, right? Now that we have those events, we come to the second question, right? Where we discuss that we don't need those raw events, we need to aggregate them. So talking about aggregation, the question comes to mind, which is, do you take the red pill or the blue pill? Which is, do you actually do pre-aggregation or do you do post-aggregation, right? So to pre-aggregate or not to pre-aggregate, not quoting Shakespeare. So if you want to pre-aggregate something, we actually use Apache Flink as our processing engine, which kind of gives us that flexibility where we have Flink jobs that are running, which consume from these Kafka topics, and they kind of can do aggregations on top. This is in use cases where we only care about aggregated events, right? And we'll discuss those cases actually later where we actually need this, right? But let's say there are some cases which demand this, and some use cases where we actually need different types of aggregations, right? Where we need to group by on one column and also maybe on another column, right? We can't do pre-aggregation there, right? So for that, we kind of need events coming in as itself as logs, and we need some kind of aggregation that happens in sync. I think that's what I also Karthik talked about. So we need our sync to also perform really fast aggregations and not just be kind of like a log engine, right? So to do that, we kind of use sync. And as I think you all might know, the sync for us here is Apache Flink. Which brings us to the sync slide, which is Pinot is what we use for use cases where we cannot do that pre-aggregation and we need aggregation once we have the data in our Kafka, consumes it. So we kind of discuss why Pinot is coming in here and how it helps us do pre-aggregation by exploring a use case. I think that kind of will help us understand a lot better, like how we do this, right? And cool. So this is how our event collection framework kind of looks like from a bird's eye view. As I talked about, we have front-end events, we have back-end events. So front-end events is made up of text impressions, back-end events is pub/sub events, or we have logs. All of these are pushed to Kafka, right? So Kafka is our magician that has everything here. And from Kafka, we either have a Flink job or we don't have a Flink job, depending on if aggregation is needed pre or post. And then all of this data from Kafka can directly be consumed by Pinot. We're going to discuss how it's used. The first use case that we're going to explore is our observability overload here at Blinkit, which we call Sonar, right? So I'll just briefly explain the use case, right? So we had people in the business who kind of wanted real-time visibility on some of the core order metrics, right? So for example, today, how many orders did we get? Simple question, right? But in real time, right? And maybe what's our gross margin value? What's our average order value? How many items did we deliver? Out of which how many were canceled? Basic metrics like these, they wanted in real time. And we know that it's a very, very bad idea to query replicas for this, which we won't do. So here's what we need, right? So we have order events that are already coming in Kafka, right? And let's say this is how it looks like. We have an order ID, we have maybe the status of the order, and we have the timestamps. And timestamps always move linearly, right? So it's 10, 11, 12, 13, time always moves ahead. That's how life works. And what we need to do is we need to perform upserts on these events because we kind of only care about the latest state of an order. We don't care about what happened historically, at least here for our use case of order metrics, right? So we need these upserts. And to support these upserts, we need some semblance of primary key. Right? For example, over here, we would need our order ID to be a primary key because, of course, that's how upserts would work for us. We also need a SQL-like interface, at least right now. It's because it helps folks get onboarded easily, and it also helps us read things easier, right? Like SQL is something that the whole data team is much more comfortable with and has experience working on. So we need a SQL-like interface. For example, right, the metrics that I talked about. Let's say we have created an order table. We would need to do simple things like sum of total cost. It becomes a GMV. We would not want to write like something out for that, right? So SQL should work out of the box for us. That was another need for us. Coming to the last need, which was performance, right? Because this is going to be something that's going to be used across the org, across the business by a lot of folks who just want to keep refreshing things and want to see exactly what's happening on the ground, right? Because they are very curious folks and they want to know if there is something going wrong. People report things immediately. If they see there is something going wrong, they just post a message saying that what's happening here. And for that, they would need to actually see this data at millisecond latency. So what's important for us is fast queries and repeatedly hitting the table, the database. And there are also use cases where we need historical data, right? So for example, what is the order count now, right? So how was it like a week ago? How was it like a month ago? How was it like a year ago? Like, we want to see how you're moving. If they see something wrong in the patterns, people kind of raise it, saying that, what's happening? Things are not going well for us. So they want that visibility also. And all of this problems that I mentioned is very effectively solved by Apache Pinot. So for past queries that we have pluggable indexing. And this helps us because our queries don't change much, right? Because these are just core metrics that are going to remain constant. Sum of total cost is always going to be GMV, and we're going to always have filters maybe on a city or on our store. The store is what you see when you open the app, right? We serve you from a dark store. So we want to see those events, and the filters kind of remain consistent. And we also have timestamp filters. You want to see it today, you want to see it a week ago. So these are things that are going to remain constant for every refresh. So for a constant set of filters, we need indexes that make the query really, really fast and efficient, right? So that's something Pinot provides out of the box. As Karthik discussed, it has inverted indexes that we really use on our filters, like cities and stores have an index. And we also use sorted indexes in cases where we have IDs that need to be sorted, right? And we also need real-time ingestion because, as we discussed, all of our data is in Kafka, and we need to consume from Kafka. And Pinot can natively consume from Kafka. We also needed a SQL interface, which again is provided. We also have other things like we have lookup joins that we can perform. In cases where, for example, I talked about stores and cities, right? There is actually a store city mapping that we have, but it doesn't have to be a real-time table, right? Because how often are these mapping going to change? Probably every hour, not every minute, right? We don't really update it that much. So those can be tables that we look up things on, right? We don't have to keep them in real time. And also we have the concept of hybrid tables where, as I discussed in our observability overload, we query historical data, and we don't want to save everything on in as live data in Pinot, right? We want to keep something in the cold storage in S3, which can be queried for later use. And also Pinot supports full and partial upserts that we also use for use cases like this, where we need to perform upserts on a key. So using Pinot, this is how we have kind of architected our observability platform, which is Sonar. Let's say the stickman is a user without a face. But let's say the user has access to the UI where he or she sees photometrics. And on top of this, we have a cache, which is there because a lot of people load things at the same time. We don't want to kind of burst things, but it's a very small cache. And then we also have authentication because not everyone needs access to everything. People only have access to the metrics that they really want or need to have access to. And the UI is powered by the API, of course, and the API is powered by Pinot for real-time data, and we have S3, which is going to be our cold storage, right? So the API hits all of these tables and powers UI, which again has a cache and authentication. So very simple architecture, which is very effectively powered by Pinot, and it's kind of one of the most adopted platforms that the data team has built. I think you would see it everywhere being used in the organization.
When you said you have a cache layer here, so anyone say in a 5-minute time period, they're seeing how many orders are placed today. They'll be seeing little bit still, like 2-3 minutes.
So our cache is not actually that big. So the thing with Pinot can actually hit Pinot like a lot, and we don't have to kind of have a cache on top of that. This is when multiple people are querying the same metric at the same time. It's a front-end cache. So if the number of orders, right, is being queried.
It can be at max 1 minute scale.
Yes. So we have a very small timeline.
And this Sonar UI and everything, it's like you have built it in-house. Like,
yeah.
Little bit on topic. Did you consider build also for the use cases? Like what are specific things? Like I think lookup joins is one of the factors which you had.
And also upserts is something that we really needed because we only care about the latest platform, and Ruby doesn't really need to support have upserts.
Like overall architecture, and just thinking from the overall architecture, the historical data aggregation, I get it. That Partners also can do, Pinot can also do, or any other like whatever we have aggregation that also you can. with respect to the real-time log metrics that you were saying with respect to, say, historical data comparisons of, say, these, say, certain days, certain times, this many orders were coming in, this many. Why not look into, say, API log, say, through whichever we are consuming from Prometheus Grafana, that historical data that will give much more clarification, say, through the funneling. Say someone came into the system at this time, and then he went to the cart or he went to the order, he did the final full layer it is giving. But there's something like Pino, where he was looking for that from the business architecture. I'm trying to look into the part. I have a little bit explored it, but not Pino in depth. So I want to understand your perspective, which like overall architecture and overall business ROI from a data ROI perspective, the Pino clicked into it, and it justified the cost of running real-time service in a way.
So coming to like the two questions that you asked, right? Why Pino and why the real-time architecture is needed? Answering the second question, we need real-time because we kind of pivoted to quick commerce, right? So where we kind of deliver orders in like 10 minutes. So that's how our whole order life cycle is for, like 10 minutes. Within 10 minutes, it's all done. Right, so you want to know immediately like what's happening. It cannot be near real time. Also, it needs to be real time. Like seconds of latency is what max we can afford. Right, and people need to see what's going on wrong, because if you wait for 10 minutes to know what's going on wrong, it's going to be too late. There are going to be so many orders that get impacted in our service. Or as a business, we care about things in real time because we are quick commerce and we want to be proactive on things, right? So we also have. I think I'll discuss some other use cases that will make it clear like why actually we need things in real time. And the reason why we went with Pino is again these two things, like as you said, the join part, and also the very primary thing was upserts. We really wanted upserts in real time and also partial upserts that are very well supported natively in Pino that Druid does not offer us. And I think Zomato team will also talk about like how we benchmark things and saw like how we picked up.
SQL type 2, type 3, all type of like upserts are supported by native in Pino.
Yeah, I think so.
Type 2, type 3.
What do you mean by type?
No, it generates a history.
You get all the updated rules. So there are two ways where you can also access the entire history, what you updated, and also there's a way you can just get the final state.
Okay, like in Delta format, like the checkpointing is there,
Very similar, but Delta also kind of compacts it later and all of that. Whereas in Pino, that kind of compaction is taken care by the minions and all of that. Various segments are getting aggregated after a while. That is fundamentally the same. You're creating some kind of Delta files on which you're then using it for file to kind of.
I think we have this written in like segments for a given primary key, so it's written in the segments. And you can actually get all the given keys, or also just do an upsert and get the latest key based on timestamp. So it just takes the max timestamp and gives you only that one.
Also, there's another use case where you're pivoting on one.
Like how many users are currently there in the
I will get you that.
So basically, I wanted to know what is the throughput that that a system is taking currently.
Currently live at like peak, they can be around like 20K, 30 users who are running
20, 30.
like 20-30K.
20,000 people. Okay, so
Who
these
are
are
running
like,
into like let's say 18, 19.
so these will be people who are, let's say, running those dark stores, and who are these?
So I think it's primarily meant for like people in the like fake source and safe source who are using this, and also people in the generating. And I think we tried this project, but right now I'll come to that. We have actually split it into a separate platform for our store ops and for our warehouse ops. I'll come to that.
Just a couple of other questions. The SP, are you using the Trino or like Presto connector which Pino provides, or like that is the,
because we have cases where we need to do like a lot of joins, and dimension joins are only up to a point. So
that is the Pino Presto connector that is powering that. And again, I'm not sure if you can. What is the cluster size of Pino, and how many servers, etc. If you can share, I'm not sure.
It will be better if you address all the conversations in the whole loop.
Oh, sorry. Yeah, so I think the information was more about like what is the size of a cluster, kind of traffic that you kind of serve. I'm not sure if I can like mention it. Like I mentioned.
Yes.
The people on Zoom are there are 2400 chats.
Right. So those are, I think, older ones. Those like inside that.
Cool. So coming to the second use case. So after
Guys,
Can we focus that one place?
yeah. If you have questions, we're very happy to have a discussion with you. Instead of just discussing with people sitting next to you, let's have the discussion with everyone. But I think once you're done, we'll open the house for discussions again.
almost done. So coming to the second and last use case that I'm going to kind of discuss is our ad platform. Apart from this is actually coming to the business use case where we actually power things with Pino, right? Other than just like a dashboard where people can see things, we also power our ad platform using Apache Pino. So how do we do that? Cool. So in our app, right, we have actually a lot of vendors who actually want to promote their product, right? Like a company, a B2B startup that wants to promote what they have to offer, right? So these are ads, right, that we serve. And people want like a performance feedback loop, right? Like how many impressions do those campaigns get? How many people are actually looking at them? And out of those, how many actually click and how many actually order and how many actually get converted? And it's kind of helping their business out, right? So this performance feedback loop, they need these events aggregated in real time, right? Because they want to see what's happening with the campaign that they are running. So this performance feedback loop is again powered by Pino. And coming to the campaigns, these campaigns itself, all the data which are events, right, being pushed in our frontend app are being tailed by our entire architecture, which again takes clicks and impressions. We store them in Kafka, comes to Pino. And we also show aggregated metrics to our brand partners, right? So we want to have this thing where, like, for example, if someone has paid for 1,000 impressions, right? We want to show them only 1,000 impressions. After that, we want to switch and we want to serve another brand, right? So every brand kind of sees they have paid for this, they've gotten this. And out of that, what is the performance that they have, which again powers the first part, the feedback loop, right? Again, based on what we have in the metrics, we rotate these ads and only show the impressions that are necessary or what was paid. And we kind of periodically have a ad inventory, right? And the ad inventory gets rotated based on metrics that are aggregated and queried using Pino by our ad service platform. So this is another really critical business use case where we actually save a lot of money by powering it in, because with sub-second latency, we can make sure, because impressions are something that's high throughput, right? Like imagine how many people are looking at the campaign at the same time. It's going to be so many people are looking. Right? And we have to kind of process key, what after this number of impressions, quickly switch to the next ad so that that ad gets that impression. And every impression that we show more than required is actually like wastage of money for us, right? Because we only paid for this much impressions and we want to show only that much. And based on that, we have a feedback loop. They can say, I need more because I'm seeing a good conversion. So maybe I'll pay more and give me more space in your platform. Right? So things like that are completely powered. It's the heart of the ad platform. So apart from that, we have a lot of other use cases where we power Pino. One is our performance monitoring, where other than core order metrics, we also have like our store team and also a warehouse team, where we have our dark store. People who run these stores want to see what's happening inside their store, right? Like the orders that are being delivered, the orders, like the wastage that is happening in the store and things like that. So the backend team kind of uses Apache Pino to power these performance metrics on like things that are happening in the store and in a warehouse. These are not the core metrics, but metrics that are happening at a store level or at a warehouse level, things like that. So we have a lot of supply jargons like, put away, like the GR and things like that. Metrics are powered through Pino on the backend side of things. So we have these dashboards. And we also have another use case for app metrics. So in app, right? So whenever you see like an O page or things like, we are not serviceable here, it's actually an API request that goes, and it's actually 200, right? But if we get localized API calls, which are like or which are like not serviceable at a particular area or a particular place, that means there is something going wrong and we can actually do something about it. Like let's say that in a particular area outside Gurgaon where we don't serve, a lot of people are seeing the O page. That means we need to service them. We need to actually open a store there. So things like that, which are covered by our app metrics, and we also maybe can get error pages that are too hard in nature. And if there is a lot of traffic in that error pages, that means our app is doing something wrong. And maybe we rolled out something wrong and we need to kind of fix it. So proactively acting on things before it has that impact, as someone saying that, what, things are broken, we want to be proactive about things. So all these cases related to that are also powered by Apache Pinot and our event aggregation platform.
You were mentioning that the dark store team and all these operations team use these dashboards.
Yeah.
Have we integrated them in the applications which they use, or they use the Sonar UI URL?
So that's what, like, there is a separation there. Sonar is for just like the core metrics that we have, right? And we also have separate metrics that are only for a store manager, right, who manages the particular store that we have in location. So they only see metrics for their store, which is managed by the backend team who pushes these events. We give a period table to them, create indexes, and they kind of have the queries running on their service. So they have a dashboard that they create. We don't really come there. We just make the data available to them and promise latency by creating proper indexes.
So my question was a little different. Like you could have a separate analytics dashboard. Maybe there is authentication and different teams have different dashboards. But the other thing which I know is that you can integrate these in the application. Maybe an app which is there with a dark store manager. So
so that's how we do it. Like it's not a part of any, like it's not part of data analytics. It's
like handy available on the same.
It's powered by the team. Like we have like a team called StoreOps that only caters to the store events, and they power it through their application. We don't give it through data application. The work for us is to make sure that they have a table which they can query, which is sub-second latency, and they can actually do those filters and get data quickly. That's why we make available to them. But other than that, it's their job to actually make
where they want to integrate.
Exactly. So it can either be dashboards that they create or in the app.
Do you put some rate limiting or anything like that, or is it open?
So we kind of evaluate queries that we run and we create proper indexes, and we also kind of have timeouts on the tables. Say, for example, we know that Pinot cannot have queries more than 1 second. Right? Like that's like a very bad query that they are running. So we kind of block these queries. We kind of pick them at timeout, but that doesn't generally happen because we work with them. We make sure that they are using the proper filters. They let us know what are the fields they will be querying, and we work along with them to make sure that the queries are optimized. And the queries are fixed, right? Like they are only like it's not like analytics where they run random queries. We don't make it available. They can only run specific queries, right? And we make sure that these queries are optimized based on indexes.
What are the chances that one team can bring down the complete system for others? Is it limited? Or the chances are high. Like,
so these are like separate tables. So like for example, you can get
you can have tenants define and ensure that only one tenant goes down. So you can have tenants for a team. Suppose that StoreOps will have one tenant with their tables, and that kind of ensure that there is some limitation on the CPU that they can take for the system table. And if it goes down, the other tenant is not in. So you're right, one can go down, but you can isolate that by using the right tools. I think also gives some very
we can set a timeout.
Every query and default timeout. As well as you can segregate the hardware resources for this is the structure of the tenant. You need only these two servers to supply the data.
So these are the use cases, and now I'm opening up on this time. Yeah.
Before what are you using to analyze the data? Second question on the same thing, like did you try to use the data dot like as far as I got, like for the real time analysis, you said that you wanted to know like how many orders are punching, like what is the error rate or whatever the other metrics. So same thing for that, we use the data dot in Zomato. Like did you try to use that for analyzing the data?
I mean, which data dot? Like you talk about the order metric.
Data dot is there's a tool we use in Zomato. We use the same thing. Like it gives the aggregated data for every for every event. So it is simply integrated, and we keep on sending point data, like one order is punched, next order is punched. So you can like distinguish also, like put a filter on that, like let's say for a particular task, so how many orders are punched, what is the basis going on, but it's a data point on there. So how want to know, like did you try that or not before within the Pinot?
So I, like, if I'm not wrong, a Datadog is a platform for like mostly devs, right? Like app related metrics that we want to see, like how many APIs were hit in the given time and those aggregations. We also have that, which is powered by, I think, New Relic, where we can actually see how many API endpoints were called at this time, what is the number of counts, what is the aggregate events and stuff like that. But that's not like something that we can integrate outside, right? Like if you want to create a dashboard, like not on Datadog, but on a different platform, where backend teams want to cater and have more control over what's happening. Right? Maybe they want to have a Google Auth where only a particular store manager only sees his store comment, like things like that. But Datadog is mostly for like devs who want to see like overall system, like what's happening, what is the status of that. That we don't use Pinot for, that we have New Relic for, where we actually push these events. If what is a 200, if it was a 400, we kind of have those metrics, and we have health and checks like that on New Relic, which are powered there.
Thus, I assume this infrastructure will be in-house, right? Your Pinot infrastructure would be on your own service. And
we use like StarTree.
But the price
we deployed the Kafka system.
I think you'll also not get latency with use cases of latency will also we talked about events. So my question is like how much you put in event. For example, so there is an order event. How much data should I put? So for example, in the front end, so put like order button. This is an event, right? Now should I put also like order value, order time, or simply just order ID, or I will pull rate the backend, or like how much data put in an event?
Oh, that we don't actually really have like a say over. So these are events that are used by the backend teams to have information. So these are actually decided by the backend team. We don't say we need these entities and we need these entities to be there. By default, order metric that is being pushed by the order team, right, has almost every attribute of a given order, right? So when you do a checkout, right, your order ID it's generated by the backend, your order value, your weight, all the items, things like that. These are already decided by the backend team. We don't say we need like these fields like that. We kind of process those fields and have aggregation on top. But on the fields, there is no limitation key like you can only push these or we don't need these. That we can do when we process. Like we can have filters and say.
बेसिकली अगर दूसरे सिस्टम पे जाना पड़ा लेटेंसी ड्रॉप हो जाएगा कहीं भी ज्वाइन करना पड़ा लेटेंसी विल ड्रॉप फ्रॉम मिलीसेकंड्स टू सेकंड्स रियल टाइम वैल्यू
Related to the ads part, like
I'll reiterate this fact. I agree with it. Go ahead.
No, so they are the same. Like one is my clicks and impressions are being aggregated, are being passed on to the aggregated values are being passed on to the backend.
Yeah.
Take decision like whether I need to show this ad or not.
Yeah.
One part of it is the brand partner who are running ads.
Yes.
So you give real time visibility to them as well.
They have our ad partners, right? They kind of pay us for impressions. Like they say we want maybe 10,000 impressions in a day. That's how much we want to serve. So we kind of show them how many impressions were actually shown, and then out of that, how many actually clicked and how many was converted.
Actually, if they pay for 10,000 impressions, can go in 1 hour.
Yeah, then we switch.
Distributed equally, right?
Yeah, then we switch to a different campaign where we can actually serve those. So our goal is to optimize. We don't want to show a campaign more than needed, and we want more ad folks to be served what they need. So we don't actually give that part that we do. We have the metrics where we actually rotate things, but we show them like, you know what, you got what you paid for. And like, this is what was the conversion.
This visibility is on, let's say, for today, I want to see, I'm a brand partner. So can I check metrics for yesterday's campaign or
so
campaign?
That is for today we power through Pinot, and this is anyway written like to a full storage, and we have historical data. So if someone wants to see like for example how historically things have happened, we can pull it out. The ad team kind of pulls out from our it's not related to Pinot, they query our analytics platform where we have things on like our press tool.
No, I mean, like,
Real-time dashboard doesn't show, but I think we have a data team.
so to answer your question, what happens is that just to stop that, we use the Pinot data sources. But in order to show the visibility for the brand, we have an algorithm. They usually report it at 12 hour lag. So the brand
that's-
visibility gets 12 hours.
So that we use our
That's
select data because they don't need to actually see. This we use only for.
One question, like,
You clean up historical data after a point of time. How long will you keep the
In
historical?
Pino, you mean, right?
Yes.
Yeah. Pino, we have retention that we set for tables.
And this retention rate, is that, what is the deciding guide? Is it because of the cost of the storage or because if you have more data, the performance may be impacted? What is the?
It actually, what you said, and also depends mostly on the number of events that are coming through. If we have like a lot of events that is high throughput, then we can have really high retention because we have modern memory. And another thing is based on use case. In some cases, we only need to show things like maybe the last 7 days performance only required. The rest can be queried from a backend analytics query because we have the data anyway in S3 cold storage, which people can query through Tree.
My question is, what difference? If my use case needs me to keep data for 2 years, is it the right place?
No, because we cannot keep live data for 2 years.
No, you can. We can keep it. So basically, like there is a hot and cold thing. There is something as tiered storage. What you will do is you will, after let's say 7 days, you can put the data in S3 or any other deep store, and then you can query from that. Of course, that will move the latency from milliseconds to seconds. So it is slightly coupled within seconds, but you can automatically configure when to push the segment from deeply coupled server to a deep store.
So, say, for example, a business use case is like that you want to search tickets, right? Normally, people will search recent tickets, but in some cases where there is an escalation, you will want to go back 2 years into the system and look up for a ticket for a customer.
You can do that. Yeah.
This is what we like have in the dashboard that I showed for Sonar, right? We have historical data in a cold storage which is S3. So with Pino, we only serve real-time queries for live data where we have less retention, and we have a cold storage which is based on tier storage where we have pushed data to S3, but then we don't actually query that frequently because it's low latency. It's not as high latency as what we have with live data because it's in memory. So if it is 2 years, right, maybe you keep 1 week's data for really quick debugging and things on a dashboard, and 2 years of data is something that's on S3 on cold storage where you kind of have like. If there is a escalation, you run like a slow query ad hoc based on what you need, and you get that data also. So we have all the data, but live data we have segmentation based on what is required.
The cost you want to pay for that.
Yeah.
one question I have, like, you mentioned about events like happening. Sometimes we need to roll back the events. So do this cater this issue also?
What do you mean you need to roll back?
Rollback of events, for example, if I place an order, payment has happened and everything has happened. At the end of the day, the order get cancelled. So a lot of
So that's also an event.
yeah.
Basically absurd. So it happens through time linearly. So we'll have the latest date. So that order will be cancelled.
Okay, sure.